and go. Okay. Yesterday, or actually when I saw you guys on Tuesday, we looked at the process called long division. There's another type of process that can be used for dividing polynomials, but it only works on certain kinds of polynomials. So I'll show you which kinds in a moment, but first I want to see the process, how it would work, just by using what we know about long division. Let's see. Kylie, do you mind closing the door? Sorry, it can get distracting. Thank you so much. Okay, now I told you I asked you to take out a different color. I'd like you to set this up using long division, but I want you to put this number, the 1, in a different color, and then all of the coefficients in a different color when you set this up. Before we begin, which term is missing? The x squared. So let's go ahead, make sure that we recognize that, 0x squared. So I'm going to set this up as x minus, but then I'm going to put the number 1 in a different color. And I'm dividing this by, I'm going to put the 3 in a different color because it's a coefficient, x cubed. And then I have a plus, I'm going to put the 0 in a different color because it's a coefficient. And then x squared minus 4, I'm going to put in a different color because it's a coefficient. And then x. And then the 2, I'm going to put in a different color because it's a coefficient of x to the 0 power. I'll say that again. It's a coefficient of x to the 0 power. Do we know why it's a coefficient of x to the 0? X to the 0 equals 1. So we can see it as 2 times 1. Good. Awesome. Okay, let's just keep moving through. You can work in one color now. Olivia?
For the x minus 1, should the negative be blue?
The x minus 1. Actually, the negative, don't make it blue. Just keep it as the 1. And I'll show you why in a moment. Okay. All right, now when we, any coefficients that show up, I want you to write them in that different color. So for example, when I look at this and I say what times x would give me 3x cubed, what would it be? 3x squared. What would be the coefficient? 3. So I'm going to put the 3 in a different color. And then I have 3x squared. And I follow the process of long division. So distribute that through. 3x squared times x would give me 3x cubed. 3x squared times negative 1 would give me negative 3x squared. And then I have to subtract. So subtract, subtract. And 3x cubed minus 3x cubed cancels. 0x squared plus 3x squared would give me 3x squared. And now what times x would give me 3x squared? 3x, good. I'm going to put the 3 again in that different color because it's a coefficient of my answer. So I have 3x. Distribute that through, so 3x times x would give me, oh, I forgot to carry down my pieces, sorry. Carry down that negative 4x. Carry down that plus 2. And now 3x times x would give me 3x squared. 3x times negative 1 gives me negative 3x. And subtract, subtract. 3x squared minus 3x squared cancels. Negative 4x plus 3x gives me negative x. And bring down that 2. And now what times x gives me negative x? Negative 1, but I'm going to put that in a different color. Distribute that through. Negative 1 times x would give me a negative x. Negative 1 times negative 1 gives me positive 1. And then I have to subtract, subtract. Negative x plus x cancels, and 2 plus negative 1 gives me 1. And this is a remainder. So in that different color, I'm just going to make sure I know how to write my answer. Plus 1 over the divisor, x minus 1. Now, if you didn't quite get the different colors, not super important. You may want to look at mine just so you can see how these numbers will transfer. That was the process of long division. Catherine. Did I make a mistake? Katie?
Oh no, I just have are the negative signs supposed to be the color?
So the different colors that I have are supposed to be the way they are. You'll see in a moment why. Okay. Catherine, did you have that question? Or is, okay. Okay, I'm going to show you the process of synthetic division. Synthetic division lines up the coefficients. That's why I had you write them in a different color. And it works with the zero value of the divisor. So if I'm thinking about which number or which polynomial was the divisor in this problem, x minus 1. What would be the zero value of x minus 1? So if we set that equal to 0, positive 1. So what you're going to do is you're going to put the number 1 in just a little box. And then you're going to line up the coefficients. So I'll just kind of write what I'm doing. Place the zero value in a box. And then you're going to line up the coefficients of the polynomial you're dividing into, so aka the dividend. So what would be the coefficients that I would line up next to the box? The 3, the 0, the -4, and the 2. And you can see those lined up with the number under the divide side, the 3, the 0, the -4, and the 2. Okay, you're going to leave yourself a space, and underneath that space you're going to create a bar. I know this is weird. Okay, the next step is you always bring down the first term, the first coefficient, if you will. So we're going to bring down this 3. Why is that so big? So bring down the 3. I don't know why it's so... There we go. If you want to give yourself a little note, you would bring it down. And then you're going to always multiply by the 0 value. So you're going to multiply by that number in the box. So I'm going to take the number 1, and I'm going to multiply it by 3. So multiply. Now, where do you think we're going to put the answer to 1 times 3? Up underneath the 0. The answer goes here. Yes, Jaden knows the process. So this is the answer. This is where the answer goes, and then you will add straight down. So now we add the numbers. So what is 0 plus 3? 3. And the process continues, just like long division. So what is 1 times 3? 3. So I put my answer here. You multiply again. And you add straight down. What's -4 plus 3? -1. And now multiply again. What is 1 times -1? -1, you put your answer in the next line. And you add straight down again. 2 plus -1 would give you what? 1. Where do these numbers show up in your answer from long division? As the coefficients. Notice we have 3x squared. We have 3x. We have -1 as the constant. And what is this number in the back? The remainder. So this process of synthetic division gives you your answers in coefficient form. You do have to remember that when you place your answer back into the format you need, your answer is going to be 1 degree less than the polynomial you divided into. Because, for example, when I divided x minus 1 into the 3x cubed, my answer was 1 degree less than x cubed. It was x squared. So I'm going to place these numbers back into answer format, and my answer becomes 3, and then I'm just going to use the different colors just to match the previous problem. 3x squared plus 3x minus 1. Oh, whoops. That's the coefficient. Minus 1 plus the remainder of 1 over my dividend, x minus 1. And that would be your answer. All right, I'm going to pause the video for a moment. So this new process will only work if the divisor is in the form of x plus or minus a number. So notice on the previous example, our divisor was x minus 1. That's why it could work with synthetic division. So for example, you could do this one with synthetic division. You could do this one with synthetic division. But what about if we're looking at these bottom examples? For which of the following can synthetic division not be used? The first one and the third one, right? Okay, let's see. Let's practice this again once together, and then I'll have you try the next one with your partner. So go ahead to the next page. Try the following. First thing is always true, you're looking for missing terms. Even if the constant is missing, you're going to have to place in a 0 for the constant. Looking at this example here, are there any missing terms? No. So let's see what we remember from the first page. What number is going to go in the box? -1, the 0 value. So you're going to put in -1. If you're like, wait, how did we get that? It's because you set y plus 1 equal to 0, and the 0 value goes in the box. What numbers do we line up next to the -1? 5, -6, 3, and 1. What do you do first? Bring down the 5. And then what? Multiply. What's -1 times 5? -5. Put your result as the next spot. And then add straight down. -6 plus -5 gives you -11. What do we do next? Multiply. So -1 times -11 would give me 11. Add straight down. What's 3 plus 11? 14. -1 times 14 would give me -14. And then what do I do? Add straight down. 1 plus -14 gives me -13. Now, how do I put my answer back into the form it would need? This is the coefficient. The coefficient of what? Y squared, right? Because you're taking y cubed and you're dividing it by y, so it's going to be 1 degree less. So it would be 5y squared, and then you just go downwards. Minus 11y plus 14 with a remainder of -13 over my divisor, y plus 1. Some of you might be like, oh, I'm liking it better. We'll see. Go to the next one. Try this with your partner. Make sure you take into account missing terms. Okay, so try this one. Check your work. You should have x squared plus x plus 1 plus the remainder of 2 over x minus 1. Okay, we're going to extend your understanding of synthetic division just a little bit more, a little bit more depth. And we're going to be focusing first on what does the word factor mean. There's different ways you can look at a factor. First is a noun, which is just 2 quantities multiplied together. So for example, you could look at like 5 times 3 is the value of 15 factored, because it's 2 quantities multiplied together. As a verb, is just to, if you're factoring something, means to express as a sum or a difference as a product. So for example, it might look like x squared minus 4 factors down into the sum and difference as a product, x plus 2 times x minus 2. This is just an example. Or the last type of factoring that you were going to be looking at is if you're looking as a factor of another number. For example, 2 is a factor of 4 because the remainder is 0 when 4 is divided by 2. This is going to be the definition we're focusing on today, a factor of another number. So let's go ahead and let's see if we just fully understand that. We're going to focus on, let's try answering this question. Is 4 a factor of 21? Why not? You're right.
You can't get a remainder of 0.
Good, because the remainder is not equal to 0. The remainder does not equal 0. Now, you guys know that from middle school, elementary school, whenever you were taught how to take 21 and divide it by 4. But now we're going to extend that understanding to polynomials. So if we're asking, is x minus 1 a factor of the large polynomial, you would determine if it's a factor. Well, if you're doing it by synthetic division, what would you put in the box? A 1. And what would you get out as a remainder? If it's a factor? 0. So let's just practice synthetic division one more time, and then we'll continue to move on. So put the 1 in the box. What do you line up next to the 1? 4, -3, 2. Am I missing any terms here? No. -3. And what do we do next? Bring down the 4. And multiply. 1 times 4 is 4. -3 plus 4 would give me 1. 1 times 1 is 1. 2 plus 1 is 3. 1 times 3 is 3. -3 plus 3 is 0. So is x minus 1 a factor?
Yes.
This is our remainder, so yes. X minus 1 is a factor, and essentially we could say x minus 1 times the quantity, if I put this back in answer format, times 4x squared minus 1x plus 3. That would equal our big polynomial, 4x cubed minus 3x squared plus 2x minus 3. So is it a factor? Yes. If a polynomial is a factor of another polynomial, the remainder when doing long division, or when doing any type of division, synthetic or long, will be what? 0. Now this is going to help extend our understanding of what the remainder theorem states. If you divide f of x, which is x cubed plus 1, by x minus 1, how could we determine if x minus 1 is a factor of that polynomial? How could we determine quickly? Or just let's answer the question. Is it a factor of the function? Catherine, you're shaking your head. No, you're correct. Why is it not? Yes, the remainder is 2. How did you know that? Ah, we did it at the top. Nice. The remainder is equal to 2. If you didn't remember that, if we look back at the notes, we actually did this exact same problem right up here. So I love that Catherine says, no, it's not a factor because the remainder was equal to 2. Now, what if we actually evaluated the function at 1? Let's quickly remind ourselves of function notation. What is that asking you to do? Plug in 1 into the function f of x. So it would be 1 cubed plus 1. What's 1 cubed plus 1? 2. What do you notice about that? It's equal to the remainder. This is actually a theorem that we have called the remainder theorem. So what do you notice? It's equal to the remainder. And this fact is actually so helpful that we have a theorem in mathematics called the remainder theorem. And we'll see how it's helpful with the next 2 examples. The remainder theorem states that the remainder when dividing x minus c into any function is going to be the same as the value of f at that 0 value c. So if the remainder is 0, that means that that is actually an x-intercept. It's a 0 value. Okay, so let's see how this theorem can be useful. Well, let's say you want to know if x minus 1 is a factor of this. Synthetic division would take some time. Long division would take some time. Use the remainder theorem to determine if x minus 1 is a factor. So notice, why would synthetic division take so long? You'd have to put placeholders in for x to the 97th, x to the 96th, x to the 95th. That would take forever. So the remainder theorem is actually can be pretty helpful. What would we plug in to determine if x minus 1 is a factor? What would we plug in? We'd plug in 1. We'd plug in the 0 value. So if I determine what is f at 1, 1 to the 98th is pretty easy to determine. Minus 1 to the 72 power is pretty easy to determine. Plus 1 to the 45th power minus 3. What's 1 to the 98th? 1 minus, what's 1 to the 72 power? 1 plus 1 minus 3 would give me negative 2. So is x minus 1 a factor? No. Therefore, no. So you could say f at 1 equals negative 2. Therefore, no, x minus 1 is not a factor. And if you extend that graphically, that would mean that x equals 1. It's not an x-intercept. Okay, so example 2, why don't you do this one with your partner? Use the remainder theorem and synthetic division to find f at c, so f at negative 1. And just make sure that you've confirmed with both ways. Synthetic division, that the remainder equals the value of the function at the c. Your answer, make sure that it is that you've done synthetic division correctly and that you have checked it with the evaluation of the function. Some people noticed that they didn't get the same remainder, and that's because they forgot those placeholders. Just be careful about that. The placeholders will get you sometimes. Yeah, that's it.